Hey students, this is lesson 7.5, proportions in triangles. In this lesson, we are going to learn how to use the side splitter theorem and the triangle angle bisector theorems to solve problems. Go ahead and do the review here and I'll check back to you. All right, so here's the deal. The side splitter theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So in this one, XR, that ratio of XR to RQ is equal to the same ratio on the other side of the triangle, SY to SQ. So if XR equals 4 and RQ equals 4 and YS equals 5, then SQ equals 5. If XR equals 3 and RQ equals 6 and YX equals 4, so here we have a ratio of 3 to 6. We need the same ratio in the other one, so that would be 4 over 8, since both ratios need to be 1/2. All right, and a corollary to that is if you have parallel lines and they're split by, if parallel lines split two transversals, then they split those transversals proportionately. So go ahead and fill in 9, 10, 11. You can check back with your answers. All right, let's use the side splitter theorem here to figure this one out. According to the side splitter theorem, since these two lines are parallel, it splits those sides proportionally. So we can write a proportion like this: 9 over 4x minus 2 equals 12 over 3x plus 2. And we'll just say that's the side splitter theorem. Okay, and then using the cross product property, we can say 9 times the quantity 3x plus 2 equals 12 times quantity 4x minus 2. Cross products property. And then we'll just use the distributive property and the properties of equality to solve that for x. And we get x is 2. All right. You go ahead and try that. And actually, you're just going to fill in the proper reasons for each of those. Okay, in this one, we're going to use the corollary to the side splitter theorem to find a missing length. And what that corollary says is that if you have parallel lines cut by transversals, those parallel lines cut those transversals proportionately. So I can write a proportion from this information. The missing x over 62 has to equal the other side proportionately, 70 over 56. Using cross products property, I get 56x equals 4,320. Divide both sides by 56, and I get x is equal to 77.5. All right, you try that. Oh, let me just put this in. This is the corollary to the side splitter theorem. All right. Another related theorem is the triangle angle bisector theorem. If you have a ray that bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangles. So in this figure, you can see that this CD over DB, those two sides are going to be proportional to CA over AB. So to find the value of x here, we can take 9 over 15, the two segments that it splits off the bottom, 9 and 15, they should be proportional to the sides that are adjacent to those two. So x over 25. Then using cross product property, that's the angle bisector theorem. Cross products properties, we get 15x is equal to 9 times 25, which is 225. So dividing both sides by 15, we get x is equal to 15. Okay, so go ahead and try a problem like that using the angle bisector theorem. All right, that's it for the lesson. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.